Example number 8 is a real-world scenario. The table shows a university's budget in millions of dollars. So in other words, this 65 is $65 million over a 10-year period where x equals 0 represents the first year in the 10-year period. We want to use a graphing calculator or Desmos, and today we'll be emphasizing Desmos, to create a scatter plot and decide which better represents the data, a line or a parabola. We'll then use our regression feature on our graphing calculator, which we're using Desmos, to find the model that best fits that data. We have the Desmos steps listed here, but I'm going to go over those in detail with you over on Desmos. And then we'll predict the budget of the university after 12 years. The first thing that I want to do is create a table of data. So I'm going to go to the Add an Item button, which is the plus sign, and I'm going to add a table. Notice that I have an x1 and y1 values. So I'm going to enter my x values in the x1 column and my y values in the y1 column. So as I do that, I can space between each line. It'll start eventually actually predicting it, and you can get your data. Now I'll put in my y values starting with 65 and continuing. Once I've entered all my data points, I want to zoom in to these data points to see my scatter plot. So I'm going to use the little zoom button over here at the very left side, right above that 2. So when I hit that zoom, I can see my scatter plot. To me, it almost looks like a great big check mark, but it's definitely not linear. It does have a quadratic shape or a U shape to it. It's kind of cut off at 0 because we don't do negative time, but I can tell that it's definitely a parabola. Back over in my notes for part A, I can say that this is definitively a parabola because the values decrease and then increase. They definitely don't go in a straight line. The next thing that I want to do is I want to tell Desmos to approximate a parabola that fits this data. So I'm going to use the standard form of my quadratic equation, but put it into the language that Desmos will understand. We want to put in the standard form of a quadratic equation on the second line, but we need to use the variables in the format that Desmos understands. So since we used an x1 and a y1 in our table, we're going to use an x1 and a y1 when we put in the standard form of the equation. So this is y is equal to ax squared plus bx plus c, but using y1 and x1, and then also using the approximation symbol, or also called the tilde, instead of an equal sign, so that Desmos knows that we want it to approximate the values of A, B, and C. So we can see that it does give us our parameters here, A, B, and C, and we can transfer those to our notes. Again, we're using the standard form of the equation and filling in A, B, and C off of Desmos. I get y is equal to, and I'm going to round this a little bit to the hundredths place on each of these, 1.49 x squared plus 0.51 x plus 39.98. Probably could have just called that a 40. Now what we want to finally do is use the model that we created, this equation, to predict the budget of the university after 12 years. Now remember that years was my x value, so that means that everywhere that I see an x in the equation, I'm going to plug in 12, and I'm going to solve for the budget y. So let's do that. I'm going to say that y is equal to 1.49 times 12 squared, and continue to fill in a 12 in the next place, 0.51 times 12 plus 39.98. If I put all of this in my calculator, I'm going to get a value of y equal to 260.66. Putting that into the context of the problem, remember that y was our budget in millions of dollars. So to write our final answer, or our budget, that's equal to $260,660,000.